Welcome to another week of material, and this week we are looking at chapter 16 in the textbook, starting on page 415, host microbe interactions. So the idea behind this chapter is how do microbes affect their hosts. In particular, we'll be thinking about how microbes, and again in particular, we'll be looking at bacteria almost exclusively in this set of lectures. How the bacteria get into you, how do they interact with your cells, how do they interact with other elements in your body, and then we'll look at one topic in particular, how they make you sick. So we're going to start in section 16.3, which begins on page 418 with principles of infectious disease. And first things first, there's just some terminology to try and remember, and we'll work our way through those different terms. So, what is a pathogen? Pathogen is a disease-causing microbe, can refer to a bacteria or a virus. Could even refer to a prion or a virion. Anything that can cause a disease. You could even extend the term to helminths or protozoans. But so a pathogen, a disease-causing microbe. Colonization. That refers to the microbe's ability to establish itself within a host and multiply. Again, we think about bacteria. A single bacteria is very, very, very small. If a single bacteria was the worst kind of bacteria you can imagine, and if it was to unleash all of its nasty chemicals, that single bacteria couldn't do you any harm. You would not notice the effects of a single bacteria. So most infections, most bacterial infections, they need to multiply. They need to grow inside the host, and they need to reach a certain number, and then they have this mechanism called quorum sensing. They can detect that that number's been reached, and then they can all launch an attack at the same time. And that mass attack can then have a real impact on the host. Like an army, you wouldn't send one guy, as the soldiers turn up, you wouldn't send them one by one into the battlefield. You would amass your army, and then you would send it off. An infection. When a microbe has a parasitic relationship. So parasitic means that one organism benefits while the other organism is harmed. And typically, yes, the parasite benefits at the expense of the host. In order to properly apply the term parasite, the two interacting species have to be different. So, for example, a dog couldn't be parasitic upon another dog, technically. There are other terms that you should familiarize yourself with too, on page 416. Mutualism, commensalism, parasitism, but I'll let you do that in your own time. So you get an infection. And there are many ways the body can respond to that infection. The first way is you may have no noticeable response. No symptoms, no signs, or indeed at least signs and symptoms mild enough to go unnoticed. So likely that all of us have some kind of pathogenic bacteria and virus within us. In fact, I would say it's almost a certainty, but not all of us are going to experience the negative effects. So an infection where you don't notice it is called subclinical. Our diseases that can be passed from person to person are known as infectious diseases. Oh, sorry. So actually we'll cover that in a second. If you do get the disease and you do experience signs and symptoms, which we'll look at in a second, then it's called an infectious disease. So a subclinical disease, you have the pathogen, but you don't know it. An infectious disease, you have the pathogen and you have some signs or symptoms. The pathogen is affecting you in a noticeable way. That leads us into slide 3. Signs and symptoms, there is a difference. Symptoms are subjective. So pain, for example. Currently, there's no machine you can sit someone down in, or there's no machine you can attach to somebody that will register how much pain they're feeling. Pain is a very subjective effect. Nausea too. There's no objective instrument to detect if someone is suffering from nausea. Signs are objective. So a rash, for example. If you were to show a rash to 100 different doctors and 90% of those doctors saw that patch of skin, for example, and said, yes, that's a rash, you can see it, you can diagnose it, that's a sign. Pus formation, swelling, these are all things that you can see. Typically you can see them. Fever, you can use a thermometer and you can objectively measure somebody's temperature. We've talked a lot, I've mentioned several times about the idea that you have this budget within your body. And you have so much budget you can spend on your immune system. And typically then, when you have one infection, your immune system, you can kind of imagine them going out and fighting that infection. But then that can lead you open to other infections. Or the infection might affect your body in some way that makes another microbe, another pathogenic microbe, have an easier time to get in. So down here, a respiratory illness that infects the mucociliary escalator. That is the cilia on your respiratory pathways. They're always beating upwards. They are then expelling materials that you get caught up out of your lungs so that you swallow them. If one disease stops that process, then another disease can get in and could lead to pneumonia in this case, which is, pneumonia is a general term meaning lung inflammation. So you get one disease, that is the primary infection. It opened the door for another disease. That is then called the secondary infection. In terms of that budget, the first infection is taking up a lot of resources, and then a microbe that was otherwise not causing harm, now it's an opportunistic microbe and it starts to proliferate and cause disease. So the ability of a microbe to cause disease comes under the heading of pathogenicity. Primary pathogen, then a microbe or virus, or those other pathogens that causes a disease in an otherwise healthy individual. So plague, malaria, and measles and influenza. You're going about your business, you're feeling fine, and then you get hit with one of these diseases. And then, kind of riding on their coattails, we have these opportunistic pathogens. They don't have the ability to cause a disease in someone who is healthy, but they can start to cause a problem. They're one of those, like they are the prisoners and the wardens. If the wardens go away, the prisoners break out and they start causing trouble. So these opportunistic microbes might be what we call part of our normal microbiota, or they might be part of the environment. Normal microbiota are the microbes that live on us and in us all the time, most of them not harming us, some of them even helping us, but when conditions are right, they can be opportunistic. In the environment, microbes like Pseudomonas. Pseudomonas found in large numbers in the soil. On to slide 5. And pathogenicity and virulence. Now, the term virulence sounds like it's related to viruses, but it's a general term that describes the degree of pathogenicity, not just a virus. So a bacterial will have virulence factors. One bacteria can be more virulent than another bacteria. One protozoan can be more virulent compared to another protozoan. So a highly virulent organism is more likely to cause a disease. So the more the virulence, the worse the organism, at least in case of causing a disease. A highly virulent organism is likely to cause a disease, and it's likely to be a more severe disease. So Streptococcus pyogenes, the one that causes strep throat. There are different strains. Some of them are more virulent than others. A more virulent form of strep can turn into flesh-eating bacteria. We've looked at some examples. Let me just check this one. Sorry, I did a quick check there to see if I could find out whether the flesh-eating bacteria version of strep had a lysogenic infection, but I couldn't find it particularly easily. But we have seen examples of bacteria that have been made more virulent because they have been infected with bacteriophages, and the bacteriophage has put its genome, the prophage, into the genome of the bacteria, and then the bacteria has access now to a new set of genes. And there are many cases where the toxins, the very nasty toxins that bacteria can make, are only thanks to the phage that put them into the genome of the bacteria. That virulent strain of E. coli, for example, and virulent strains of diphtheria. So, lots of factors play into the virulence of an organism. We'll look at all of the steps, all of the mechanisms that are involved in how a pathogen causes a disease. It has to attach. So a bacteria that can attach better than another bacteria is more virulent. A bacteria that can survive better than another bacteria is more virulent. A bacteria that can spread from person to person more easily is more virulent. A bacteria that makes toxins, etc., etc. All these things are important. They're not particularly, they may not be linked. You can have a bacteria that's very good at sticking to cells but doesn't make a toxin. or you can have a bacteria that's good at evading the immune system and makes a toxin, but it's not particularly good at sticking into the organism. Okay, so finish this first section. Slide 6. Know some terms: colonization, infection, parasitic, subclinical. Let's add in there subclinical versus infectious disease. Be able to recognize a sign from a symptom. Be able to recognize a primary and a secondary infection. Be able to distinguish between a primary versus an opportunistic pathogen. Know what virulence is, and know the ideas behind virulence factors. Okay, that's this first section done.